is there a limit for the group?
Is
Like
there
how
a
many
limit?
people?
See,
Uh,
see, we are just making two people group because we don't want that four, because the projects are not that much huge project that it will take a a larger manpower. So that's why we are saying that only two people, if they are two people group is fine, because projects are not very much hard or very much time consuming, because they are short projects. Okay, just to give you an idea how we basically work in big data and how things are actually dealt with. Okay, so yeah, so like if you want that you need to have a three or four group, then in that sense the project should be at least uh, it should be like कि वो justifiable हो at least. Okay, it should be a long project, it should have a proper things, right? So we are keeping it with two only. Okay, two is good. Okay, you two people can easily synchronize between themselves, right? So that's why.
The project would be on Spark only.
No, no. You can work in Spark. You can work in data science, like machine learning. Okay, so yeah, you have both the choices. You can't work over it. See, I would not say that we will be working over Hadoop or a project over Hadoop, because that becomes a bit difficult task, because for project to do a project over Hadoop you need to have a proper cluster environment. Okay, and since we are working over these standalone devices, so that becomes a bit a bit difficult, right? So that's why we are saying that it's better या तो आप Spark पे work कर लो, project कर लो, या फिर आप अपने data science पे machine learning पे काम कर ले. That becomes much easier, and implementation is also much handleable. Okay. Yeah. Okay, fine. Okay, so let's start with a Spark session. Give me a second. I'll share the screen. Okay, I hope the screen is visible to you all, guys. Screen is visible.
Yes, screen is visible.
Okay. Just okay. So yesterday we were discussing about RDDs. Okay. Uh, that how RDDs are basically helping us, or or you can say they are the fundamental data structure for Spark, right? So there are two operations involved with the RDDs. One is transformation and action. Okay, but before that, let's again revisit some points with respect to RDDs. So RDDs are resilient distributed data set. R stands for resilience. Okay, D stands for distributed, and the other D stands for the data set. Now, what this resilient means? This means that the RDDs are fault tolerant. Now, how fault tolerant? Because RDDs are maintaining tag, which is directed acyclic graph, or you can call them as lineage graph. Okay, since RDDs are making these lineage graph, so we are able to, we are able to, basically recompute the missing, or you can say any stage at which we are basically uh, facing any fault, or fault basically. So previous to that stage, we are able to uh, capture that stage and restart the execution from that point. Okay, it's not like we have to again restart the process from the scratch, right? So because of that, we are because of this DAGs, we are able to deal with the fault, um, in the fault while execution of any of the task or job, right? Then second, then the for distribution. So distribution basically data, because distributed basically because क्योंकि आपका data जो है, because since we are again working in a cluster environment and we have multiple nodes with us which are holding the data, so already your data is in a distributed manner. Okay, so this D basically represents the distributed data which we are dealing with. Okay, then the data set. Now the data set basically that it represents the data you can work with. Okay, now this data is it's not like you have a constraint that only a certain set of data can be evaluated. No, you can work over your JSON files, you can work with the CSV files, you can work with text files, you can work with databases, because we have seen that if we have JDBC or ODBC connections with the database, so we can also work over the databases, okay, with respect to Spark SQL. Okay, so this is what your RDD stands for. Okay, so RDD basically enables you to to work over your data. Okay, and when you are working with the data, your data, even if the data is, or not the even if, but as your data is in a distributed manner, it's stored across the cluster. So RDDs are able to evaluate such kind of data, and also the variety of the data which we are receiving. Okay, or you can say various files you can deal or process with respect to RDDs. Now see, हमने बात करा था कि RDDs में partitioning होता है. Okay, now this partitioning, see this partitioning जो हम RDDs में perform कर रहे हैं, these are logical partitions. Okay, these are not the physical partitions. Okay, now these logical partitions are basically done so that कि आपका data quickly process हो सके in a parallel format. Okay, आप across the cluster अपने data को process कर रहे हैं. Partitions अगर हम RDDs के through होते हैं, then it is much more, it becomes much more easy for us to process the data in a much faster speed. Okay, and uh, yeah. So these are, so with partitions, don't get confused that we, because this might be, you might get confused that कि already data हमारा partition form में data nodes पे stored है, हम उसे फिर further क्यों partition कर रहे हैं? So no, the data or the block you are processing is all is processed, and the partitions which are then further being created with respect to RDDs are logical patterns which are done by Spark itself. Okay, we can also manually do that if, let's say, the your processing or your job requires that you need to do the manual partition. That then that can also be done. Okay. Also, with respect to RDDs, we also discussed one another thing, which was caching. Okay, so we are able to cache the RDDs. Okay. Yes, someone saying something? Yes. Please kindly mute yourself. Just hold on for a minute, please. Just give me 5 minutes, guys. Okay. Okay, yeah. Sorry, guys, for keeping you waiting. Yeah. So, the another concept which we were discussing was the caching of the RDDs. So, caching is basically done so that whenever, let's say, if you want to, store a particular stage, or you want that for a particular um, what I say, like say, let's say there are a number of steps involved in your program, and for a particular stage you want to store your data, or you want to store the RDD, then you can cache that particular RDD in the memory. Okay, and all the caching of the data is done in the in your RAM. Okay, all the RDDs are cached in your RAM. So whenever Spark feels that there is a memory bulge it is facing, so in that sense, what Spark does it automatically it automatically spills the RDDs which are not in use, okay, or the cached RDDs which are no longer in use, um, uh, or let's say uh, are no longer in use, or the frequent ones are being kept, and the ones which are not frequently used are being moved to your physical storage. Okay, so this is how your caching of the RDDs take place. And um, so so this is these are some features which with respect to RDDs we have discussed. Then comes your these operations. Okay, so what are these operations? Let's discuss that. Okay. Yeah. So, Spark basically has two types of operations. One is the transformation, and another one is the action. Now, transformations, RDD transformations are functions. Basically, these are functions that take an RDD as an input and produce one or more RDDs as the output. Okay, so whenever this basically means that you have an RDD. Okay, and transformation is basically converting one RDD into multiple RDDs. Okay, you can create multiple RDDs from an existing RDD. Okay, so this is what the transformation basically means. Okay, and since we know the fact that RDDs are immutable, so you cannot make any changes from in this particular RDD. What you can do is you can create another one. Okay, you can perform the transformation, but you cannot alter the RDD. Okay, and transformation, when you're performing this transformation, this does not means that your RDD is basically evaluated. Whatever data your RDD is holding, that data is evaluated. No, transformation does not imply that data is being, you know, processed, right? So this is what your transformation is. So transformation are basically lazy operations on an RDD in Spark. Okay, so these are transformation are lazy operations. Okay, it creates one or more new RDDs and are executed only after an action is performed. Okay, transformation is just basically changing from one RDD to another, or creating RDDs from one RDD. Okay, but this does not imply that evaluation is happening. This only takes place when an action is performed. Okay, now there are some some functions related to transformation. So there are examples like map. There is a map function for transformation. Sorry. There is a filter function. These function we'll be using when we'll be doing the practical work. Okay, then filter is another function. We have another function called reduce by. Just excuse the writing. Okay, so reduce by, map, filter, these are certain operations, or you can say the functions which we use for doing the transformation work. Okay, then in transformation as well, there are two kinds of transformation basically. So one kind of transformation is your narrow transformation, and the other one is your wide transformation. Okay, so what this narrow transformation is, uh, just hold. Okay. So, yeah. So, narrow transformation. Yeah. So, narrow transformation and wide transformation. So, now what this narrow transformation is? So, narrow transformation, it's basically so in narrow transformation, basically, it is the result of map and filters, and such that the data is from a single partition only. That is, it is self-sufficient. Okay, so basically, narrow transformation basically means that you are using a single partition, and whatever you are processing in through that single partition, all the required information is present in that particular partition. Okay, an output RDD has partitions with records that originate from the single partition. Okay, so let's say you have one RDD. Okay, let's say you have one RDD. Okay, and you have created, let's say, there are 2 3 partitions of this particular RDD. Okay, now whenever these partitions are being performed or being processed, uh, whatever data is required or whatever data they are holding, it is sufficient when they are being processed. Okay, it's not like that some of the data is missing or something like that. and also the output which is being generated will be respect to this particular partition only. Okay, so this is what your narrow transformation is, and the operations, or you can say the क्या कहते हैं, your functions which are basically doing the narrow transformation is your map, your filter kind of operations, or your flat map type of operations. Okay, we'll see the flat map operation as well. Okay, so these are the operations which are basically doing the narrow transformation. Basically, they are working over only single partition. Okay, then comes your wide transformation. Now, wide transformation is basically the result of functions like your reduce by key, okay, or group by key. So this basically means that the data required to compute the record in a single partition may live in many partitions of the parent RDD. Okay, so basically when wide transformation is performed, this reduced by key is basically what it is doing, that the data or the data required to compute in a single partition, let's say data यहाँ पे जो हमें process करना है, this does not imply कि जो data हम process कर रहे हैं वो सिर्फ यही हो, वो उसके different other partitions में भी हो सकता है, but the condition is that these all the partitions should have a single parent RDD. ओके यहाँ पे नैरो ट्रांसफॉर्मेशन में क्या था कि जो भी डेटा हम प्रोसेस कर रहे हैं वो सिंगल पार्टीशन में ही प्रेजेंट है. It's not like data, we need data or the data is present in other partitions. Okay, जिस partition को हम process कर रहे हैं उसमें वो data sufficiently present है. Okay, but in wide transformation, the fact is that data is present in this single partition as well, and the other partitions which are also present. And the condition is that the data or the partitions which are created should have a single parent. Okay, so this is what your wide transformation is. Okay, so this can be understood. Let me give you an example. If I can. So I'll just add. Yeah. Okay, so this you can understand it by, let's say you have this narrow transformation. So for narrow transformation, the depiction is like that you have these partitions. Okay, and the transformation is done from this partition to this partition only. Okay, so data is being processed and the output is also from that single partition only. Okay, this is the input partition and this is the output partition. Okay, this and the all these partitions have a single parent, right? But for the wide transformation, the scenario is that you have these these partitions, okay, and also you have blocks in it, divisions in it. Similarly will be here. Okay, similarly here you have partitions. Okay, but here what happens is that the transformation is not just from the single partition or from this partition. It can be from other as well. Okay, it can be from this as well. It can be from this as well. Okay, likewise for this ओके, सो गॉट द पॉइंट कि हम और इन सब के जो पेरेंट आरडीडी है वो सेम होगा. Okay, so here when the transformation is basically happening, it is not that the data which is being processed is residing here only. It can also reside on the other partitions, but here the data which is being processed should reside only on this particular partition. Okay, it will not be looking into the other partitions of the RDDs. Okay, so this is what the difference between your narrow and the wide transformation. Okay, then comes your action. Okay, transformation basically हमने डेटा को आप ऐसे समझ सकते हो कि हमने डेटा को मैनिपुलेट किया है. ठीक है, हमने डेटा को एडजस्ट किया है so that we can do the final action over it. Okay, इसको आप ऐसे समझ सकते हैं जैसे जब हम मैप रिड्यूस करते हैं तो मैप रिड्यूस में आपने देखा होगा कि हम मैप में क्या कर रहे हैं. मैप में हम डेटा को टोकनाइज करके और फिर उसमें की वैल्यू पेयर कन्वर्ट करके और हम वर्ड का हम एक बैग क्रिएट कर रहे हैं जहाँ पे वर्ड है और उसका अकरेंस आ रहा है. राइट, तो ये एक ट्रांसफॉर्मेशन हो गया. दूसरा ट्रांसफॉर्मेशन क्या है कि हमने रिड्यूस के साथ हमने क्या किया उसको हमने उसके जो जो टोकन्स बने थे उनको एक सिंगल फॉर्मेट में कन्वर्ट कर दिया. मतलब रिड्यूस के पास क्या पहुंचा, हडूप और उसकी नंबर ऑफ अकरेंस. ओके, लेट्स से द वर्ड इज हडूप और उसके नंबर ऑफ अकरेंस का एक लिस्ट फॉर्मेट में हमने डेटा को रिड्यूस कर दिया. ठीक है, बट एक्शन कब परफॉर्म हो रहा है. एक्शन जब परफॉर्म हो रहा है जब हम रिड्यूसर के थ्रू उसको एग्रीगेशन परफॉर्म करके और जब हम उसे डिस्प्ले पे ला रहे हैं. जब हम आउटपुट को प्रिंट करा रहे हैं या हम आउटपुट को कहीं स्टोर करा रहे हैं. दिस इज व्हाट द एक्शन इज. ओके, बिकॉज व्हेनेवर आप जब देख रहे हो जब हम जार फाइल एग्जीक्यूट करते हैं मैप रिड्यूस की, we always give the output location. Okay, so giving the output location basically means that we are directing that you need to perform the action. Okay, so it is something similar to that कि अगर हम word count program अगर यहाँ imply करेंगे, so all the mapping, all the filtering, all the reducing of the data will be done by the transformation. Okay, action will be when we basically do the operation of producing the output. Okay, when we are basically executing the or we are basically we are instructing that the output should be generated. Okay, that is when your action basically takes place. So action in Spark results final result of RDD computation. So whatever computation you more with respect to Spark. Okay, then you can do that if you want a better understanding about the Spark. Also, what I'll do, I'll share some ebook with you, which also I have referred to with Spark. Okay, so I'll share those books as well with you. Okay, so this is all about your basics of Spark. See, okay, and now we'll move towards the practical part. Okay, so for that, we'll again come to the Cloudera. So yesterday I told you that we have Spark incorporated here as well. Okay, so one of the method is that simply open your Spark this terminal, and you need to just type Spark hyphen shell. Okay. So when you write Spark hyphen shell, this will basically open your Scala Spark with Scala. Okay. So if you want to work with Scala language, then you write Spark hyphen shell. Okay. And if you want to work in Python, okay, with Python language, so what you simply write is py. Okay, this will give open the Spark shell with Python. Okay, so this one is Spark shell. So note these things, that if you write Spark shell, you will get Scala, Spark with Scala. Okay, and if you write PySpark, you get Spark with Python. Got the point? Yes, everyone.
Yes, sir.
Okay. ओके सो सी हमने जब पाइस्पार्क लिखा है यहाँ पे, तो आप देखो यहाँ पे जो ओपन हुआ है स्काला के रेस्पेक्ट में हुआ है। ठीक है, आपने पाइस्पार्क लिखा तो आप स्पार्क वर्जन दिस एंड पाइथन वर्जन दिस इज बीइंग देयर, एंड you have these three arrows. Okay, so this is what is present in your Cloudera environment. Okay, this Cloudera image. Now you see the version of Spark is quite old, version 1. That means this version does not include Spark streaming and graphics. Okay, so this is where the limitation of this image comes. Okay, so what you can do is, I'll show you. So what I have done is that, see, I have this Cloudera environment. Also, what I've done, I've also installed an Ubuntu image. Okay, and in this Ubuntu image, I have installed the Spark. Okay, so that installation, this Ubuntu installation and the Spark installation, that also I'll share with you. Okay, so how to install. So I think this is the link for installing the Ubuntu VMware image. Okay, and for Spark installation in Ubuntu, yeah, this one link. Okay, so that also I'll provide this link to you all, guys. So there are a proper, steps to follow how you can, install Spark on your Ubuntu. Okay, so these two resources I'll provide to you. Okay, so what you can do is, in your same VMware, okay, what you do, import this Ubuntu image, and then once your Ubuntu image is set up, then you just simply install follow these steps for Spark installation, and you are good to go with your Spark. Okay, and here what will be the benefit will that you will be having the latest version of Spark. Okay, so the latest version, and also there will be no constraints to that, which things will, something will be working and something will not be working. Okay, that thing will not be there. Okay, So these things also I'll be sharing with you. But for now, what we'll be doing, we'll be working over this Cloudera image only. Okay. And let's see how things basically work. Okay. So for that, I have this practical file. Yeah. So this file also has a proper, step by step things, how we basically do the practical things here. So Spark Shell. So this basically give you the Scala version, or you can say to work with Scala for Spark. Okay. So that we have done already. Now see, the shell provides code assistance. So for example, type sc dot followed by tab key to get the list of options associated with Spark context. Okay, so let's try with that. Sc dot tab. See, all these are the operations which you can use with Spark context. So SC basically means your Spark context. Now, if you can recall, when we were discussing with respect to Spark architecture, the first thing which is being done with respect to any kind of program you are working, Spark context is invoked. Okay, remember this thing, guys? Yes, everyone. You remember? Okay. No worries. ठीक है. So Spark context is invoked, and these are the operations you can use with Spark context. Now let's come ahead. Now see, let's say if I want to, read some file from my HDFS. Now remember that since we are using this Cloudera environment, and this Cloudera environment is being set up over Hadoop. Okay, Hadoop is being set up, and Spark is basically set up over this Hadoop, right? So we'll be using the storage space called HDFS with respect to this Cloudera image. ठीक है, तो अगर मुझे HDFS से कोई फाइल रीड करना है, so what I'll be writing, val readme equals to sc.text file, because I'm reading text file, and in the brackets I'll be giving the location of the text file. Okay, now this location will be your HDFS location. Okay, now if you have your file in some particular directory, so the location will start from that directory. Okay, so let's try with that. So well, but before that, let me check. Okay, let me open another terminal, and there I'll check Hadoop. Okay, what is the command to list out all the files of HDFS?
FSLS.
Yes, FSLS. So Hadoop FS hyphen ls and slash. Okay, so these are the files I have in the HDFS. Okay, so let's see. So what is the command to basically see the content of the file?
Cat.
Yes, cat. And let's see what this dummy.txt holds. Okay, this dummy.txt does not hold anything. So let's go with the with this big, yeah. Okay. So this is the data in the bigdata.txt. Okay, so let's read this file in your Spark. Okay, so what is the command we are writing? Well, I'll give the variable readme equals to sc dot text file bracket. Okay, and in the bracket, I'll just write big data.txt. So this is the file name, data.txt, right? Okay, let's just cross check the file. Okay, and let's execute this. Enter. Now see, देखो हमने रीड किया एक वेरिएबल में रीड मी जिसमें स्पार्क कॉन्टेक्स्ट के थ्रू हमने टेक्स्ट फाइल ऑपरेशन यूज किया है टेक्स्ट फाइल देखो यहाँ पे कहीं पे होगा see this is the text file operation we are using with xsc spark context and we have read this file. Okay, now what this basically this line actually interprets basically यहाँ पे ये जो rdd create हुआ है या आप रीड में ये जो वेरिएबल क्रिएट हुआ है this is basically a pointer to your this file. Okay, a pointer is being created to basically read this particular file. Okay, so this is what your transformation has taken place. यहाँ पे हमने transformation apply किया है, ठीक है? Now, once we have now the parameter text file method is the location within some directory on the HDFS. ठीक है? किसी directory में होगा या ऐसे ही होगा. This was an RDD transformation. Okay, thus it returns a pointer to an RDD which we have named as readme. You can see from the return line that the readme is a pointer to the RDD. Okay, and this RDD is holding this file. Okay, now let's perform some RDD actions over this file. Okay, now हमने transformation create कर दिया. Now इस पे action कैसे perform होगा, ठीक है? Now for action we have the command as readme.count. Now this count is the action function we are performing. Okay, over this pointer which is readme. Okay, now what I'll write readme dot count is the function we are using and enter. See, it has given me the output count 3. Now why count 3? See, the output was, देखो output क्या था इस फाइल का डेटा क्या था? Hello everyone, welcome to Big Data Training. Hope you are having a good time learning. These are the 3 lines of your file. Okay, so what this count has given us, it has counted all the 3 lines of your file. Okay, the count, the number of lines your file is holding. Okay, that is what the output is given by your count. It has not counted word by word. Okay, it has counted line by line. Okay. Now let's come to another action. Let's say if you want to find the first item of your RDD. Okay, so the command is read me dot first. See, this is the first line of your file. So it has given us the first line as printed here. Okay. So these are the actions we are performing. Okay. Now use the filter transformation to return a new RDD with a subset of items in the file. So if let's say if I want to transform another RDD, let's say from the existing RDD, from this existing RDD, I'll be creating another RDD. And there what I want that we are basically, filtering it on some subset or on some item. okay, on some particular item. Okay, so what I'm doing is that I'm using another variable. Readme is the current RDD which I'm having, and I'm applying the filter operation here. And in the filter, I'm seeing that traverse through line by line. Okay, and filter all those lines which are holding with as the word in it. Okay, so it will filter all the lines which are having with in it. Okay, so in our file, let's select one of the word. Let's select good. Okay, and according to that, we'll be using the filter transformation. Okay, I hope you all are getting, guys.
Is this line a variable here?
What
Line is equal to line dot contains. This line, is this a variable?
this line you are saying?
Yes.
So
Yes.
no, it's not a variable. Basically, it's the you can say it's the operation which Spark is using to traverse through each line of the data, and with that, it is basically seeing that whether that line is holding this word with or not. Okay, so it's an operation which is being carried out by Spark on its own. Okay, we have not defined this line.
Okay, so this line is a keyword basically.
Yes, it's a keyword which Spark is itself using it.
Oh, thank you.
Okay, so Spark lines with equals to readme dot filter. And we are using word good, right? Check it once. The contains. Okay. We are good to go. Yes. So enter. So another RDD, a pointer RDD lines with is being created. ठीक है, देखो ट्रांसफॉर्मेशन हमने अप्लाई कर दिया, आपको यहाँ पे आउटपुट क्यों नहीं दिख रहा है? Can anyone tell me? Yes. Can anyone tell me हमें ये चीज क्यों दिखी, हमें आउटपुट क्यों नहीं दिखा?
Because we are not calling lines with here.
Yes, basically we have not performed any operation, any action over this lines with. ओके हमने ट्रांसफॉर्म कर दिया, हमने रीडमी जो आरडीडी थी इसको फिल्टर करके हमने इस पे ट्रांसफॉर्मेशन अप्लाई कर दिया और हमने एक नई आरडीडी क्रिएट कर दी. We have performed the transformation, but we have not performed the action over it. So we can see the output only after we apply the action over this lines with. Okay, so how we can do that? So we can simply write count. Okay, and we'll get the count of the lines which are holding this word good. Okay, तो आप actions में कैसे क्या कर सकते हो? Lines with dot count करो, it will give you 1. Okay, now if you check it here, यहाँ पे हमारी सिर्फ एक रो में good word था. अगर ये मल्टीपल रोज में होता, ठीक है, तो वो हमें हमें 3-4 लाइंस देता. ठीक है, लेट्स से अगर वो यहाँ पे इस रो में ही 2 टाइम्स गुड होता तो क्या आउटपुट होता? let's say in this row only, good might occur 2 or thrice.
One only.
Okay. Yes. So the output will again be 1 only. Though the number of occurrence of good is multiple in this particular line, but still for Spark, it will basically consider only this as the one as the output. Okay. But let's say ये good इस row में भी होता और first row में भी होता. So in that way, in that output, we'll get the output as 3. Okay, because Spark is basically reading the file line by line. Okay, it's not reading by word. Okay, word by word के लिए हमें specifically Spark को instruct करना पड़ेगा that you have to read the file word by word. Okay, so this is what your output here represents. Okay, so it has gone through these lines with RDD, and it found that with respect to the filter which is we have applied, and counting basis and counting operation is applied over it. So after that we get that only one line contains good in it, this word good in it. Okay, so that's how your output we have that's how your output is interpreted. Okay, also one another thing is that it's not like that आप हर बार ये आप separately करो, कि आप ट्रांसफॉर्मेशन अलग से कर रहे हो, आप काउंट अलग से कर रहे हो, या एक्शन अलग से कर रहे हो. What you can do, you can also club these two things, ट्रांसफॉर्म एंड एक्शन, आप एक ही लाइन में क्लब कर सकते हैं. कैसे क्लब कर सकते हो? आपने ये किया, इसके आगे डॉट काउंट लगा दो. ठीक है, तो यहां तक आपका ट्रांसफॉर्मेशन हो गया, यहां तक आपका ट्रांसफॉर्मेशन परफॉर्म हो गया, एंड हियर आपका एक्शन परफॉर्म हो गया. तो एक ही लाइन में आपका आउटपुट आ जाएगा. सी, वी हैव क्लब्ड द ट्रांसफॉर्मेशन एंड एक्शन इन वन पर्टिकुलर कोड लाइन. गॉट द पॉइंट? तो जरूरी नहीं है आप ट्रांसफॉर्मेशन अलग से करो और फिर आप एक्शन अलग से करो, आप दोनों को कंबाइन भी कर सकते हो. दिस इज व्हाट इन दी नेक्स्ट लाइन वी आर सेइंग, वी कैन इवन चेन टुगेदर transformation and actions to find out how many lines contains the word Spark. Let's say this is an example with respect to a file which might be having Spark. Okay, so readme dot filter lines contain Spark dot count. Okay, this is what we have done here. Okay, so we can also chain the transformation and action. Okay, now let's try our word count problem with Spark. Okay, तो word count problem अगर हम Spark के साथ कर रहे हैं तो किस तरह से होगा? ठीक है, तो देखो word count का concept I hope you all remember. किस तरह से word count होता है Hadoop में? Yes everyone? Yes or no?
Yes, ma'am.
यस, यू रिमेम्बर ना दैट हम टोकनाइज करते हैं, फिर हम वर्ड का अक्रेंस उसको एक्सप्लिसिटली वन सेट करते हैं. वंस द tokenization or the once the tokenization has happened, and then reducer will basically do the aggregation, right? तो आप देखो हम स्पार्क शेल में किस तरह से उसको करते हैं. ठीक है, सो yes. So see, let's say we have this file. Okay, so we'll be writing readme, which basically our file is having this file. Okay, now upon this readme, we are basically applying the map function, and we are splitting the line by line on the basis of spaces. Okay, basis of spaces basically means that कि आपकी फाइल, आपके जो ये कंटेंट है फाइल का, that will be separate, that will be tokenized based on the spaces. Okay, जहां जहां उसे स्पेस मिलेगा फाइल में, वहां वहां वो टोकन्स क्रिएट कर देगा. ठीक है, and it will take the size of it. Then in the reduce what we have done is कि हमने reduce के through हमने clause लगाया if a is greater than b, a else b. Okay, so यहाँ पे आपके पास दो parts हैं. First part is your map, which is basically tokenizing your word. Okay, the second part is the reduce part, is called to find the line with the most words in it. Okay, तो यानी कि जिस लाइन में सबसे ज्यादा words होंगे वो उस लाइन को it will find that line. Okay, so the argument to map and reduce are Scala function. Okay, Scala function literals, but you can use any language feature or Scala or Java library. Okay, so that you can perform. Okay, so let's say let's well, simply say I'm doing it quickly so that should not. But before that, okay, this readme file has this now. Okay, no issues. Enter. So 8, integer 8. Now what this integer 8 basically means? This last line, it has given us the line which has the maximum number of words. Okay, this interpretation. Okay, so what it has done is basically उसने फाइल को tokens में convert किया. ठीक है, और tokens में convert करके उसने count किया कि कौन सी लाइन में सबसे ज्यादा number of words हैं. तो उसने find out किया कि जो ये वाली लाइन है उसने जो जो सबसे ज्यादा नंबर ऑफ वर्ड्स की लाइन है उसका नंबर हमें उसने दे दिया, बेसिकली 8. दिस लाइन हैज 8 नंबर ऑफ वर्ड्स, सो इट हैज गिवन अस दिस. ओके, अब लेट्स कम टू द वर्ड काउंट थिंग कि वर्ड काउंट कैसे किया हमने. सी वैल वर्ड काउंट रीडमी पे हमने फ्लैट मैप लगाया, लाइन को हमने स्प्लिट किया वर्ड पे, वर्ड बाय वर्ड. देन हमने उसमें मैप फंक्शन लगाया, एंड मैप फंक्शन में हमने क्या किया कि जो लाइंस और जो लाइंस स्प्लिट हुई है वर्ड्स में, उन वर्ड्स को हमने एक्सप्लिसिटली 1 असाइन कर दिया. ठीक है, तो जो काम हम मैप वर्ड मैप प्रोड्यूस में करते थे, हम टोकनाइज करते थे, एंड वंस द टोकन्स आर क्रिएटेड वी आर explicitly assigning 1 as the occurrence of that word, no matter a single word has come once or twice or thrice in the file. Okay, then ये tokenization हो गया और हमने occurrence define कर दिया. Then comes your reduce by key, and reduce by key में हमने apply किया है aggregation. Now aggregation आपने देखो यहाँ पे कैसे किया है, a comma b and a plus b. Okay, so a comma b का a plus b का interpretation कैसे होगा कि सॉरी कि आपका जो रिड्यूस बाय है उसके पास इनपुट किस फॉर्म में जाएगा, इस फॉर्म में. ठीक है, तो वो क्या करेगा, इस लिस्ट को पिक करेगा और फिर उस पे एग्रीगेशन अप्लाई करेगा. सो लेट्स से हडूप 4 टाइम्स आया है, तो एग्रीगेशन कैसे परफॉर्म होगा, 1 plus 1 equals to 2, 2 plus 1 3, 3 plus 1 equals to 4. So this is how the aggregation will perform through this. Okay. Okay, so let's go with this. See, val word count, readme, flat map. We are splitting the file basis on the basis of spaces. आप यहाँ पे spaces की जगह कुछ आप character भी दे सकते हो. Let's say आपकी file में कोई special characters हैं which are basically on the basis of which you want to divide the file. You can do that as well. Okay. So on spaces we are doing that. Then हमने map function apply किया and we are basically doing the tokenization and assigning the occurrence as 1. Once the tokenization has happened, हम reduce by key के through हम apply कर रहे हैं aggregation. Okay, so let's execute this. Sorry. There is an error. Just is giving the error. Okay. There was an extra bracket here. Okay, I'll just rectify here as well. Okay. Now, once we have done that, to perform, देखो यहाँ तक हमने जो काम किया है, यहाँ पे ट्रांसफॉर्मेशन हो गया. आपका जो भी फाइल था उसका पूरा कंप्लीट ट्रांसफॉर्मेशन हो चुका है. ठीक है, डेटा कंप्लीटली फिल्टर्ड आउट एंड रिड्यूस्ड हो चुका है. नाउ यू जस्ट नीड टू परफॉर्म एन एक्शन. बेसिकली यू नीड टू जनरेट द आउटपुट. ओके, तो जनरेट द आउटपुट you can simply use word count.collect and it will give you the output. So word count dot collect is the function to see the output and enter. See, tokenization हो गया. यहाँ पे देखो, everyone R has occurred once, U has occurred once, hope has occurred once, has occurred once, having has occurred once. All the tokenization and the occurrence is done. Word count is being performed and this word count output is being generated in the form of an array. Okay, an array is being created where the value has, where you have a string type of value and you have an integer type of value. Okay, so this is what your output is generated through Spark. अब आप compare कीजिए कि आप MapReduce में कितने lines of code लिखते थे and in Spark this code is just reduced to 2 lines. So how much eased out your work has done is being done. Okay, your number of lines of code are so much reduced and it is also very easy to debug. Okay, जितना ही आपका complex code होगा उतना it will be difficult to to do the debugging part over it. Okay, so this is how you are performing word count. Okay, now similarly, this can be done in your Python shell, PySpark shell. Okay, so these are the instructions how we basically do. See, देखो बहुत ज्यादा ना कोड में बहुत ज्यादा डिफरेंस नहीं है. यहाँ पे हम val readme लिख रहे हैं, but here आप देखो Python में हम simply what you are saying readme se.txt file. If you are familiar with Python, आप Python में जानते हो कि हम data type नहीं define करते हैं. Java में, Scala में हमें ये val वेरिएबल काइंड ऑफ हमें ये डिफाइन करना पड़ता है स्पेसिफिकली. ठीक है, बट पाइथन में ऐसा नहीं होता है. ठीक है, तो you can also try these lines of code in your this in your same PySpark shell. Okay, so I hope this is clear what we have done in Scala shell. Everyone, yes everyone, आपको समझ में आया जो हमने अभी किया? Yes guys. Okay. Okay, fine. Okay. So what I want you all to do is I'll share these files with you just now. Okay. I want you all to try all this in your Cloudera. Okay. You try it in Spark shell, sorry, in your PySpark shell and your Scala shell. Okay. You go through this file and you try all these commands in both the shells. Okay. And you can also do this joining part of the RDDs. Okay, this is also very simple. You need to just create two files. Okay, just remember this joining of RDDs is in Scala. That is your Spark FN shell. Okay. So just don't get confused because see here the commands are like val. Okay. So this will be working in your Spark shell. Okay. So try these both the things. Okay. This Python one and this joining of the RDDs. Okay. Try this and just let me know tomorrow that if you are facing any issue. Okay, everyone? Yes.
Yes.
Yes, ma'am.
Yeah, try out yourself. Okay, try to see that how things are working. Okay, and if you face any issue, if you face any trouble, just let me know. Okay, uh, we can discuss it again. Okay, one more thing which I wanted to discuss with you is that how we basically using collab. Just 91. Okay, so yeah. So in Google Colab, you create a new notebook, okay, and we have certain steps with respect to Spark installation in Google Colab. These are some steps, okay. Now in Google Colab, it is explicitly PySpark, okay, no Scala, okay, because it's a Python platform, okay. So what you need to do is follow these steps. Copy paste these steps there, and your PySpark shell will be enabled in your Google Colab. Okay, and then you can use your PySpark for you can perform your Spark streaming, you can perform your Spark ML libraries, anything, or just general Spark functions, whatever we have done with respect to this na स्पार्क का जो हम ये पाइथन वाला जो पार्ट है, ओके, आप ये सब ना वहां पे ट्राई कर सकते हो. ओके, यू कैन टेक अ वर्ड फाइल. ओके, you can take a text file, okay, and give the path to it, and you can get the output as uh, or you can use these lines, use this set of instructions, and you can see that your PySpark is basically working according to the instructions. Okay, so you need to follow these installation steps first. In follow, just copy paste these here, enter, and execute it here. The installation of your PySpark will be done. Okay, see JDK is being installed. Okay, all these things will be happening. Okay, so likewise, you can use Google Colab as well for your PySpark. Okay, that will also be handy if you don't want कि आप VMware पे काम करो या आप Ubuntu पे काम करो. ठीक है, you can use Google Colab as well. Okay, so got it everyone. I'll share these resources with you. Try these and let me know if you face any kind of issue. We'll be discussing it. Okay. Yes, VMware is too slow because actually VMware itself is not slow because of Cloudera image. It basically becomes very slow because it is consuming your, your laptop or your desktop RAM. Okay, and since you know this Cloudera image is quite heavy. Okay, so that's why you are all, facing overall situation of this your system getting slow. Okay, so that's the reason with that's the case with VMware. Okay. Yes, any other question?
I have a doubt in HBase.
Yes. In HBase.
H, yes.
Okay, so Anushka, for that, you can contact Mr. Sunil sir, so that he might better give you the answer for HBase. You can contact him. Okay, what you do is you post your query in the group. Okay, he'll answer that. Okay.
I did post it, but no one replied.
Okay, you did post. Okay.
Yeah.
Okay, I'll ask him. Okay, so that might be he might have skipped that.
Oh,
Okay. So I'll ask him that he will respond it accordingly. Okay.
okay. No, no problem. Thank you.
Yeah. Okay. 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 Any other queries with you all guys? We also have change configuration as well. Figure it. See, for the configuration now, the installation of Ubuntu when you will be doing in your VMware, no, it will give you the this link which I'm giving you now. It has the complete instruction to what settings you need to do when you are incorporating Ubuntu. Okay, so don't worry about that. So this gives you a complete set of instructions that how you will be doing the setting of your Ubuntu image. I hope it's not having much of the settings being done, just the ISO. Okay, use the ISO image for that. Okay, and I think memory is also one of the things which is being set. Yes. Processor, you can keep it as one only. Okay, no other, yeah. So memory is the thing, and also this your what was that ISO image was there, na? Yes, this CD DVD set. Okay, here you need to give the location of your ISO image for your Ubuntu. Okay, that will be there if you when you will be getting this Ubuntu downloaded in your system. No, you'll have an ISO image there. Okay, so memory, this ISO image setting, and the processors. Processor you keep it as one only, don't make any changes there. Okay, and that's it. And then how the installation will happen, all these set of instructions are very well defined here. Okay, you can follow them, they are very pretty clear. So these two links I'll give you, this installation one and installation of Spark, these two things I'll give you. I'll just copy it here in this same file. So this one is your installation in here. Okay, and this is the one, two. Okay, so these are the two links I'll be giving you. Okay, you can try out these two and you'll good to go. Yes. Any other query? Okay, guys. So, yeah. So, this is what your Spark is there. Okay, you can explore Spark. I would suggest you all guys that you explore more in Spark with this official documentation and everything. Okay, there are multiple resources available. You can go through them. It's a good thing that you get an understanding in Spark as well, because Spark is, with respect to what Hadoop was doing, Spark is much ahead in it, and with respect, and Spark is also, very much popular across the organizations. Okay, there is an extensive use of Spark among the organizations who are working in big data and everything. Okay, so that will definitely help you when if for your, let's say, if you are going for a job interview, or if let's say if you want to switch your job, in that sense also Spark will be a very, good thing to have an asset with you. Okay, a learning thing which will give you a push in your job as well. So do explore it, and if you face any issues, do let me know. I'll try my best, and definitely I'll try resolving it. Okay, so thank you, everyone. And you can post your attendance here in the chat box. And those who have done, they can, leave, no issues. Okay.